So here I have the inside function f of x is ln x, and here the outside function is sine x. So what we can do is we can just run values through this function machine and get outputs. Okay, so if I put in x equals 1, okay, I put that through the f of x, I get 0, I put 0 through my g of x, I get 0, and I can plot that point. Okay, so there's the point, plotted x equals 1, y equals 0. And I could run a whole series of points through here. In fact, I can run, we talked about how the domain of this function is going to be restricted because of the log. Well, I can put, -1 and run the function. We can see that as I run -1 through, we don't get anything out of here, so we get nothing out of here. Okay, so we have a restricted domain of negative x values because the restriction happens in the first function log, because the output of this log function, all of it is actually the domain of the sine function. So if I show just log x, there's log x, here's sine x, okay, and I can see that the domain of sine x is perfectly fine. It's the domain of the log x that's restricting the function. And if I actually just show the whole graph, okay, so I'm just going to turn these off. Okay, I'm going to run the function machine. Oops, I can't show that point, but let's run x as 10. Okay, so run that point through. Oops, need to run positive 10 through that. Okay, so I run positive 10, I get a coordinate. Right, I can show that point on there, and I can actually show the function of log of sine x. So at the beginning, it's just going to go, it's actually going up and down very quickly through here, and then as the log function, as we get big numbers into log function, the log function changes slowly, so it goes through the 1 to -1 much more quickly. Okay, so I think I can zoom into here, maybe not. Okay, so there is how we can run it through the function machine. So we have it goes through the process of going through the inside function, the outside function to get the output.